We have discussed various functions. Now continuing with these functions, let us take example 14. So we need to draw a graph of the function which is r to r defined as fx is equal to x cube. See this x cube, any power of cube, if you take any negative number, say any negative number, the cube will give you negative number. So let us place the value, and I would suggest that how to draw the graph. First, in this axis, take 0, then take certain positive value and the equal number of negative value. Say if you are taking 2, if you are taking this 2, then take minus 2. Taking 4, take minus 4. So that will give you an idea how the graph is going to be. So let us take x equal to 0 here, then 1 minus 1, 2 minus 2, 3 minus 3. So this is how this graph will unfold. Then the rational functions, these are the functions of type what? Fx by gx. So fx and gx, these are actually polynomial functions of x which are defined on domain. What is the domain? Gx cannot be 0. Please understand, gx is 0, then this is going to be infinite, undefined. So let us take an example of this sort. Define the real valued function f r minus 0. So we have defined a real valued function r minus 0. What it means is the function is actually fx is equal to 1 by x. This means that the x cannot be 0. That is why all the real numbers are possible except 0. So we have subtracted this 0. So x belongs to r minus 0. All are except 0. So you need to complete the table. And what is the domain and the range of this function? Just place these values, all these values here, and try to find out what y will be. So these are the list of y value which will come, and I hope that 1 by x you can compute. Then the domain of domain and range has been sought. This is domain and range is required from us. So the domain of all real numbers except 0. You cannot have 0. Why? This is 1 by x. You cannot have a 0 in the denominator. The range is also all real numbers except 0. So you see the graph. This graph is like this. It is not touching either x-axis or y-axis. Though it seems to be, touching slightly, but it is not. Because if it touches, then this goes to infinite. X cannot be 0. We cannot have 0. And if this is y equal to 1, y is equal to 1 by x, you take x on the other side, put y on the denominator, so x will be equal to 1 by y. So you cannot have 0 either in the either range or domain. This is the graph of y is equal to 1 by x. Then the modulus function. What is this modulus function? Modulus function is represented by this. Any value which is inside this bars is going to give you a positive value. Any value. Positive will give you positive. If you place a negative value inside these two bars, it is going to give you a positive value. So let us define formally. This is a function f from r to r, which is defined in the fx is equal to this mod x. This is a modulus function. And see, this modulus function is nothing but y equal to x. So this is okay. Y equal to x, you have seen the identity function. What about this? What is happening here? The modulus function, the y equal to x or the identity function was something like this. The straight line was the representation. What about this? See, fx will be equal to, let us formalize it. Fx will be x for any x that you put which is greater than 0. But if you place x which is less than 0, then you are going to get minus x. Okay, that will be minus x. That means you have to have a minus x, that is minus of minus x, that is going to give you a positive one. So fx will be x for x greater than or equal to 0, minus x for x less than 0. So this is the graph, because if you place minus 2, then it is going to give you 2. If you place minus 4 in a modulus, it is going to give you 4. So the graph will be like this. So this graph actually has turned down to this graph. This is the modulus function, because we are not going to negative anymore. Then the signum function. What is this signum function? This signum function is defined like this. For anything x greater than 0, it will be 1. For anything is equal to 0, it will be 0. For anything which is less than 0, it will be minus 1. So 1 minus 1, 0 and minus 1. 1, 0 and minus 1. What you can find, you can recall, you can very well recall that these are actually three constant functions. These are nothing but constant functions. But here we have signum function which include these three functions which are showing the constant value 1, 0 and -1. So this is the signum function. The domain of signum function is R, no problem. But range is only these three. As we recall that the constant function has only C as the range, because anything you put, it is going to give you a constant number. Here also anything you put, it is going to give you 1, 0 or -1. So it will be -1, 0, 1. So the graph of the signum function is like this. This is 1. If you place any value here, it will be 1. If you place any value negative, it will be -1, and for 0, 0. This is the function actually. Now greatest integer function. Say you have 1.2 and you have 1.8. It is between 1 and 2. So for these 1.2 and 1.8, you are going to take 1 as the value. If it is 3.6, you take 3. If it is 3.9, you take 3. So this 3 and this 1 which I just told you is actually the lowest or the greatest. Actually the value is low than 3.6 or 3.9, but it is called as a greatest integer function. So this assumes the value of the greatest integer function which is less than or equal to x. So such a function is known as the greatest integer function. This is represented by the square bracket. So x will be equal to -1 if it is at all between 0 and -1. So this lower value will be taken. See, everywhere lower value is taken. If the value is between 2 and 3, it will be 2. So this is the graph. How the graph is, any value between 0 and -1, it will be -1. Any value between -1 and 2, it will be -2. Any value between -2 and -3, it will be -3. So this, and again same stuff. 0, it will be 0. It is given 0. But any value between 1 and 2, it will be this 1. Any value between 2 and 3, it will be 2. Any value between 3 and 4, it will be 3 always. This is your greatest integer function. Now let us see the algebra of real functions. What will be the algebra? You can add two function, you can divide two function, you can multiply two function, you can multiply any function with the scalar. So this is what? This is the f addition of function. F is a function, g is a function. F plus g is nothing but fx plus gx. The subtraction of two function, f minus gx, is nothing but fx minus gx. Multiplication by a scalar, you want to multiply alpha with this fx, so that will be alpha into fx. Alpha is nothing but the scalar function, scalar value, and fx is the function. You want to multiply two real valued function, then just have to fx and gx will be, this fgx will be represented by fx into gx. What about quotient of two real functions? F by g, you can easily find f by x of g because this will be fx by gx. The main thing is gx cannot be 0. Let us take one example on this set operation. So fx is x square, gx is 2x plus 1. You want to find out fx plus gx. So just x square plus 2x plus 1. You want to find f minus gx. So x square minus 2x minus 1. You want to find out f into g. So x square into 2x plus 1. This is 2x cubed plus x square. Then f by gx. Fx by gx. That is x square by 2x plus 1. So x should not be equal to minus half. Otherwise it will become 0. Now fx is x root. That is, this is x to the power half. Gx is x. You want to find out f plus gx. Fx plus gx, that is root x plus x, as you can see here. F minus gx means root x minus x, like this. Now fx into gx, root x into x. Root x is x to the power half and x to the power 1. So half plus 1 is what? X to the power 3 by 2. What about division? This is half, x to the power half. This is x to the power 1. When you subtract it, means 1 minus half, or half minus 1 will give you x to the power minus half. X cannot be 0. So this is the miscellaneous exercise. Let us take, this is r and f is r to r. So this is y is equal to mx plus c form. This is a straight line. So you just have to place this value. f0 is 10, f1 is 11. Take these minus values also. And if you see, this is a straight line. So what you can get is, for x equal to 0, y is minus 10. For y equal to 0, y equal to 0, these values. For x equal to 0 you have to find, for y equal to 0 you have to find. So you get these two values and it will give you a straight line. Why this is given? Because this is actually experiencing a linear fashion. Linear fashion is y is equal to mx plus c, as you can see here. So m and c, these are constants. M is the slope, c is the intercept. This is a relation R, which is defined in Q to Q. So R is what? A comma B. You want to find out, you have to show that A belongs to R, AB belongs to R, A comma B belongs to R, and B comma C belongs to R. So this implies what? This implies that A comma C belongs to R. So we'll take this question in the later discussion, because it will take some time and I need some time, because to explain you, this is very important actually. Actually, this is a reflexive, transitive and symmetric kind of relationship. So we'll leave it for the next discussion. So till then, thank you so much. Take care.